Hello, I'm Scott Sorrell here at the ADSA meetings with Kristin Gallagher from Michigan State University. We got a Spartan with us today. Welcome, Kristin, to the Real Science Exchange.
Thank you so much. Excited to be here at ADSA in Kansas City.
Yeah, awesome. And my co-host today, Dr. Clay Zimmerman, the trusty Rusty Clay Zimmerman, and Carrie Estes. Kristin presented a poster yesterday. The title of her poster was Abomasal infusion of branched-chain keto acids alter lactation performance in early lactation cows. Kristin, tell us a little bit about the study.
Yeah, of course. So this was a USDA NIFA project that we worked through this past winter, and we were looking at abomasal infusion of branched-chain amino acids or branched-chain keto acids in the early lactation period and its effects on performance and liver health, specifically looking at its relationship to fatty liver disease. So this project, the major results from this project were that branched-chain amino acids altered milk yield, increased milk yield, milk protein yield, milk fat, but we did not see any changes in liver triglycerides as opposed to the branched-chain keto acid infusion altering and efficiently decreasing liver triglycerides.
Oh. It's interesting that you infused it abomasally instead of jugularly.
Jugularly, yes. So yes, trying to do long-term jugular infusions turned out to be a bit of a challenge, but our main objective was to deliver these amino acids and keto acids post-ruminally, and we're going to be analyzing plasma branched-chain amino acid concentration and other amino acid concentration to see how that is going to be affected. But yeah, so we delivered these to the animals post-ruminally, and we got some pretty significant results that we're excited about.
So I noticed that you infused very specific amounts of each of the amino acids. So can you tell us how you came up with those levels?
Yeah, absolutely. So we infused the branching amino acids are valine, leucine, and isoleucine. And with this study, our objective was to increase plasma branched-chain amino acids by approximately 30%. And that comes from some work done by Dr. Zhou in some previous research where he established there was a relationship between animals in the early lactation period that he classified as having high liver triglyceride versus low liver triglyceride. And in those animals with low liver triglycerides and really a lower risk of fatty liver disease, he found that there was an elevation of plasma branched-chain amino acids by about 30%. So that's where that came from. And to determine if the concentration of amino acids was correct, we did a preliminary trial where we had 6 cows of the same cohort that we were able to effectively increase branched-chain amino acids by that amount, so by about 30%.
So Kristin, I think probably a lot of our listeners are familiar with feeding or infusing branched-chain amino acids. Mm-hmm. What's the hypothesis behind the branched-chain keto acids?
Right. So again, we're interested in the liver's response to these amino acids. And unlike other essential amino acids that we might be delivering to the cow, branched-chain amino acids are not going to be metabolized in the liver. Most of the amino acids, over 80% of the amino acids, are instead going to be metabolized by peripheral tissues, so muscle and adipose tissue, and it's going to be partially catabolized to these keto acids, which are non-nitrogenous, non-amine metabolite of these amino acids. And there, these branched-chain keto acids will then be taken up by the liver, and they can be used as an energy source. And we have some cellular data that might show that these branched-chain keto acids will affect hepatocyte metabolism. So that was our target and our interest, was to understand the relationship between these branched-chain amino acids and keto acids and how they affect liver health and production.
So you saw quite a response in production to the branched-chain amino acids.
Yes, yeah. So we definitely saw a pretty big milk response that we're pretty excited about. And I will comment again that the diets or these treatments that we deliver to the cow, we fed the same diet, but different treatments, were not isonitrogenous or isoenergetic. So in our branched-chain amino acid treatment, again, these are amino acids with amine groups. We were feeding higher RUP to these branched chain amino acid supplemented cows. So I think we had, just more nitrogen available for milk production in these treatments, as well as there's some literature that goes to suggest that some of these amino acids we're feeding, such as leucine or isoleucine, can increase anabolic activity within the mammary gland, potentially increasing mammary plasma flow, activating the mammalian target of rapamycin, mTOR. So we think that there is, just delivering more RUP, but also doing some more anabolic work as well. And with the keto acids, we didn't see any difference in our milk production response, but again, we saw an effective decrease in liver triglycerides. So that was exciting.
So with your liver tag, you saw the reduction with the keto acids,
Yes.
right? But
Yep.
not necessarily with the branch chain.
Yeah, not with amino acids. So, so we're going to kind of continue to look at the mechanisms that are going to be occurring in the liver. We have tissue that we're going to be looking at gene expression relating to lipid uptake and how these keto acids might be affecting lipid uptake, beta oxidation. My lab mate, Isabel Bernstein, is going to hopefully be coming out with, we'll all be coming out with a lot of future analyses from this project. I'm excited to really go through and better understand what's happening with our plasma amino acids. We just sent those samples out last week and are hoping to get a lot of information back from that. Looking at antioxidant status of the liver, as well as we have tissue samples from muscle, adipose, and more liver tissue that we're excited to analyze.
So, Kristin, I know soy protein is high in branched chain amino acid content. So, is it possible to formulate a diet today that might deliver more branched chain amino acids?
Yeah, of course. So branched chain amino acids are really important in dairy nutrition in general. They make up over 20% of the total amino acid profile in milk. There's a lot of these branched chain amino acids that are going to be found in different forages and different protein products in our TMRs. For example, we just fed a common Midwest diet that was 50% forage to our early lactation animals. And leucine was about 1.3% of the total dry matter versus some amino acids we might be familiar with. Methionine was about 0.29% of dry matter. So even without supplementing it, just on our base TMR that was being delivered, I think what we need to be wary of is how these branched chain amino acids are going to be fermented in the rumen. Because they will become branched chain VFAs and they can have, different end products once they're fermented in the rumen. So certainly if you if you can balance for what is going to be delivered post-ruminally, for in these high protein products, you could potentially establish similar results if you really wanted to increase branched chain amino acids, plasma branched chain amino acids. It would certainly be a challenge, but could certainly be done. Meanwhile, the branched chain keto acids, this is again a metabolite, so we don't currently have a way to feed those branched chain keto acids in its pure form. So we'll see if any technology is going to be applied to that in the future.
So I'm kind of curious, Clay. We're talking about practical implications. Would we need to, maybe this is a better question for Kristin, but maybe think about protecting them ruminally with...
Yeah, so I mean, there is still, I think, a lot of work to be done to figure out, when we should be supplementing these branched chain amino acids and what they might be able to do for different herds and different dairy farmers. But I think that it certainly is there's a good opportunity that these could be things that we're balancing for in the future, and that delivering these post-ruminally can be very helpful to the animals and to milk production and health responses. So I think that's definitely a very promising subject to better identify.
Yeah. So you're going to be finishing up your thesis. You're going to be moving on. Are you going to be handing the ball off to anybody else upon your departure?
Yes, absolutely. So yes, I'm a grad student in Dr. Zhang Zhou's lab at Michigan State University. And I had a co-lead on this big project. Her name is Isabel Bernstein. And we have a lot more work to be done with this project and are super excited to better understand the mechanisms behind branched chain amino acid, branched chain keto acid metabolism. So I'm hoping to get into the industry after this, and we'll have a lot more information coming from our group.
Very well. Maybe we'll have Isabel in this chair next year.
I hope so. Yeah.
So what are your plans after you graduate?
So after graduation, I'm excited to just get back in the industry and work in technical sales and consulting, and really just help farmers and make better decisions for the herds out there.
Okay, and I understand you may want to go back to New York.
Yeah, so I'm originally from Central New York, not too far from Syracuse, and headed back to the East Coast, northeast. So we'll see what happens there.
All right, very well. Anybody looking for a very bright, very energetic master student? We've got one here in Kristin, and so give her a call. Kristin, thank you very much for joining us today.
Absolutely. Thank you so much for having me.
Very well.
We'd love to hear your comments or ideas for topics and guests. So please reach out via email to anh.marketing@balchem.com with any suggestions, and we'll work hard to add them to the schedule. Don't forget to leave a 5-star rating on your way out. You can request your Real Science Exchange t-shirt in just a few easy steps. Just like or subscribe to the Real Science Exchange and send us a screenshot along with your address and t-shirt size to anh.marketing@balchem.com. Balchem's Real Science Lecture Series of webinars continues with ruminant-focused topics on the first Tuesday of every month, monogastric-focused topics on the second Tuesday of each month, and quarterly topics for the companion animal segment. Visit balchem.com/realscience to see the latest schedule and to register for upcoming webinars.